Okay, I'm going to talk about bearing angles. Bearing is based off due north. So we're no longer making angles with the x-axis, standard position. When we talk about bearing and headings for airplanes or boats, or we're going to talk about due north, which is either 0 or 360. Being an ex-pilot, they don't tell you to fly at heading 000, they fly at 360, but you can use either one. Okay? The important thing is, this would be 360, 90 degrees to the right. East is to the right here, that's 090 heading, or 90 degrees. South is 180, and west is a 27. So these are your bearings, 090, 180, 270, and 360. 1 second. So, hey, I'm filming. Come back, please. 1 second. I'm going to pause. Oh, never mind. All right. So 180 is due south, and 090, 270. Okay. All right. Let me just come back to this. Okay. This could be proposed to you in a problem where you're going 35 degrees west of due north, okay? Well, that would be 360 minus 35 degrees. That would be also given to you as, could be 325 degrees, okay? So either way, you need to be able to know that, hey, I'm flying this, let's say you're on an airplane flying 325 degrees. Be able to know this is due north. Oh, that's 360 minus 325. That's a 35 degree difference. And you can make, this would be from due west of 270, this would be 55 degrees. That's important because now I can make a triangle and I can express this in component form. Okay? Remember, r cosine theta, well now our cosine theta is x. Well now it's really the same thing, it's the magnitude of our vector is the radius. Cosine, in this case, let's say of 55 equals x, and then magnitude sine theta, let's say of 55 equals y. Okay? So now we can, if you've got, the whole thing is just being able to break it down and knowing that this is 360 and you're flying 35 degrees due west of north, that'd be 325 heading. And you know that's 55 degrees from this x-axis, or the east-west axis, okay? So we can break it down and solve. If this was, you're flying for 150 miles, what was your westerly component? What's your northerly component? 150 cosine of 55 equals my westerly component. It would be a component form, a negative, right? It's to the left. 150 sine of 55 degrees equals my northerly component, or y, and that would be a positive, okay? All right, just some quick, skip that. This angle right here would be what? North. This is 180, so this would be 180 plus 40. From here to here is 40 degrees, so that would be 180 plus 40. Remember, we're going this way now. There's 90, 180, 220, okay? You could also make this triangle be what? Here's my western component, here's my same thing, r cosine theta. What's theta? This still is 90 degrees, each quarter is 90 degrees, so this would be 50 degrees. And if you have any magnitude assigned to your vector, whether it's speed or distance, let's say it's speed this time. Let's say it's 400 miles an hour, okay? 400 cosine 50, 400 sine 50 can give me my vector in component form. Okay? Real quick. This vector here would be, here's 50, so this is 90. Due east is 90 plus 50. Okay, some of the phraseology again might be 40 degrees east of due north. That would be 40 degrees east of due north, which would be what? 040. Okay? And again, what's your component? Draw your triangle. My vector in component form. Again, magnitude r cosine theta, which is magnitude. Okay? Magnitude r sine theta. Okay? That could give me my easterly component and northerly component in this case. We could be, what if I gave you a heading of a bearing of, let's see, 120. That would be 90 plus, here's 120, and 100 miles. This would be 120 degrees. Well, that would be a reference angle here of what? 30, because that's, here's 90, we went 30 past. 120 minus 90, what's minus the nearest axis here, okay? So now I can make my triangle here with, here's my x and y component based off 30 degrees theta. That's a reference angle, okay? All right? It's going to be a positive angle, so I know that, I just have to know that my vector is going to be positive horizontally and negative vertically, okay? Just like we had before, no different, okay? All right, that's with bearing. I want to go back to one real quick thing, and that's, we're going to have multiple components though, all right? We might have, we need to be able to break things down so we can add vectors and see what the resultant vector is. We might be flying in a Cessna that has this vector, u, but it's in a hurricane and the winds are stronger than we're able, we're flying 110 miles an hour, the winds might be 200 miles an hour. So this might be a more stronger vector. So what's the resultant vector? It would be u plus v. This is what I do. I'm doing u plus v. Notice tail of v goes on the head of u. Okay? Initial to terminal, initial, terminal. Here's my resultant vector. Oops. Okay? Okay? Which is going to be 5 minus 2. So it's important to be able to break down maybe a wind that's coming at this, at 120 degrees, at 50 miles an hour, and put it in vector form with an x, y, horizontal, vertical, so we combine it with a vector of our speed this way, and you can actually find out the resultant vector when you add these two vectors, okay? So that's when it's important to be able to break things down into using our reference angles, maybe in different settings, 360 versus the x-axis, but break things down, component form, add vectors. Also remember, when a negative vector is the opposite direction. Okay, so here's u, and minus v is basically adding the negative vector, which should be, instead of being 2 minus 4, it's minus 2 plus 4. So this would be my resultant vector, u minus v. It's just adding. So just some updates on, just to keep you fresh as far as what we actually are doing when we add and subtract vectors. Okay, we can do this graphically. All right, that's all I have. Hopefully that helps out some of these word problems we're going to get into.